this is a diagram to show you two of the special right triangles you learned in geometry. On the right, you have a 45, 45, 90 triangle, and on the left, you have a 30, 60, 90 triangle. If we look at the 45, 45, 90 first, you'll notice if the angles are both 45, which are the same, then the lengths of both of these sides also have to be equal. So if this side has x units, this side is also x units. This color coding, the purple versus the yellowish brown here, tells you the relationship between the legs and the hypotenuse of this triangle. It says if you know the length of the leg, that you can find the length of the hypotenuse, if you follow the purple, by multiplying by the square root of 2. Vice versa, if you have the hypotenuse length and you need to find the leg, you have to go the other direction. So you would have to take the length of the hypotenuse and divide it by the square root of 2. So if you're going the other direction, you have to do the inverse operation. Very similar relationships over here in the 30, 60, 90 triangle. If you'll remember, the short leg is across from the 30-degree, the smallest angle, and the longest leg is across from the 90-degree angle. And then you have the hypotenuse, which is always across from the 90-degree. If you know the relationship of the shorter leg, you can find the hypotenuse, it says, by multiplying by 2. Or if you know the short leg, you can find the length of the long leg by multiplying by the square root of 3. And then if you want to go in the other direction, you have to do those reverse. So like if I have the long leg and I want to go find the length of the short leg, I'm going to have to then divide that value by the square root of 3. Whereas if I know the hypotenuse and I want to go back to the short side, I have to then divide by 2. Now I'll have to show you here in the next video the dividing by the square roots, whether it's the square root of 2 or the square root of 3, you'll have to do some rationalizing to clean up that fraction. But you will want to keep this chart handy until you relearn those relationships for the 30, 60, 90 and the 45, 45, 90 triangles.